pizza until there is some kind of sauce and some kind of cheese. There was an excellent episode on Seinfeld about that, which they related to the abortion debate. When is a pizza a pizza? Kramer says it's as soon as you put your hands in the dough. Because Kramer wanted to be able to put broccoli on his pizza. And his business partner was like, you cannot put broccoli on pizza. And Kramer is like, I can put anything on my pizza I want. It was a funny episode. But you guys are too young for Seinfeld. Some of you have watched a few episodes, I'm sure. But you don't understand, because TV is different than it was then. Every single person in your life on Friday morning talked about Seinfeld, because every single person in your life in the 90s watched it on Thursday night. Not a couple of people, every single person. And there were no PVRs. Everyone had to watch it on Thursday night. Everyone. Nobody didn't. It was embarrassing if you showed up at work or school on Friday and you weren't able to discuss Seinfeld from the night before. People were like, you're a loser. Even if you were out doing stuff, people still thought you were a loser for not knowing about Seinfeld from the Thursday night before. It was weird. Times are very different now. All right, nobody wants a magic pen? Kale, you are a new man today. No, I'll bring it to you, because this bad boy is wireless. I know, right? Yeah. I'm going to sit in my other comfy chair.
Do it.
And see how the other half lives. Oh. Look at this guy. Woo! Somebody stop him. He's on a roll.
Do it. Okay.
Hey, zip it.
Hey, yeah. This is hard. I don't have a ruler. I'm going by eye.
It's not easy. I know, right, Kale? Everyone's like,
yeah.
Myers, you're such a moron. Okay,
yeah.
All right. There. All right.
Art.
Is he right?
Maybe. The graph.
He's pretty good. He's pretty good. Does he have everything he's supposed to have? Does he have horizontal axis labeled? He labeled it T. I think that's supposed to be toppings. Is he right? Are toppings the independent variable? Of course they are, because when you order, it changes if you want more toppings. Some of you crazy kids actually enjoy a plain cheese pizza. I do not. Some of you have religious reasons for it. I do not. Alright, so I like that. So he's good. Does he have an appropriate dependent variable? Yes. Cost. Is it labeled? Yes. Is it scaled? Yes. So he's done a good job there. Is there somewhere that he has made kind of a clerical mistake?
73. It looks like a 13, but it's a 73.
Yeah. No, because if I gave you guys points for messiness, I'd have to dock a lot of marks. Gerard.
It doesn't change.
The line, we'll come to that in a minute. That's technical. I'm talking clerical. Is there something he has written that is not in the best spot? Nadia. So he's just said that this is 12, so he hasn't done a proper scale thing here, right? Right? But we can do this thing that we do in social studies, the little lightning bolt, to say that nothing is happening in there. That's not a math thing, that's a social sciences thing. They add that in. We're okay with it though, we can use it. So that's something he could have done. Because the way he set this graph up now is he said one line is worth 12 and then all of a sudden they're worth 50 cents. Understand? Now, would I take grades away from him for that? No, I wouldn't. Okay, is there anything else you see? Gerard. The zero is over here. I would slide this whole schmozzle this way. So zero is here. And then I would slide my line. Son of a motherless goat. I would slide my line to there. Are we happy with that? Okay, Jin 1. It goes up by buck cities. So yeah, this should have been 1350. This should have been 15. This should have been 1650. This should have been 18. But again, he's still on the right track, yeah? The line's going up with each topping purchased, which is exactly correct. Now, has he made a technical error? He's done everything almost perfectly. There's one other thing. Is he right with this line, Supreet? Yeah, he sketched it. Come on. Don't lawyer ball us. Gerard.
Did they charge a fixed amount for each topping?
They charge for each topping. So is he allowed to call and say, you know what, I only want pepperoni on half of it, so I only want to pay 75 more cents? Do you think they will do that for him? No. So should these be connected? Or is it discrete? Is it discrete or continuous data? It's discrete because it's per topping. Understand? Soon as you order a topping, they're going to charge you for it. Picking up what I'm putting down? Everybody with me? Okay? So the only actual mistake that I would dock him marks for is that he connected the line. Otherwise, this made enough sense to me that I'm okay with it on a test because it's a sketched graph. Everybody cool? Kale, good job. Because it was damn close to perfect. Everybody wants to join the line. Always. How many of you joined the line? Be honest. It's a note. It's notes. Right? A lot of you joined the line. Because it made a pretty line, didn't it? Right? It made a, oh, look, so beautiful. I have to connect that. Oh, yeah. Oh, lovely. Can't get enough of it. Except, of course, you can. Because is there a fractional input? Can I ask for half a mushroom? No. Okay, everybody cool? Now we get a difficult question. We have decided, indeed, that it is not continuous. Now, the $1 million question, which isn't really worth $1 million. Is it a linear relation? Yes or no? I haven't drawn a line, so is it a linear relation? Yes. Why?
It's still straight.
It goes up and over by the same amount each time. So I can predict where the next one is going to be. Does everyone understand? So this is linear because the IV and the DV change by the same amounts respectively. Not necessarily the same amounts each, but the IV goes up by this much each time, the DV goes up by this much each time. Everybody understand? Okay? You always need to ask yourself, is it possible to have an output for every given input? And in this case, it is not. So we can't connect the line. Cool? Everybody good? All right. Let us move on, cabbages. Linear relations have 4 manifestations, of which you are responsible for all of them. We have already done 2. What are the 2 that are already done on this page of notes by this time, do you think? Pardon? Yeah, what linear relations have 4 ways they can be shown. That's what a manifestation means. We've shown 2 of them already on this page. What are they?
The steps.
Yeah, the graph. So the first one, you can make a graph, which we have already done, yes? On our graph, what's important? What do we need to remember? IV, dV, and continuous or discrete. Those are the important things to remember on a graph. What's the second way on our sheet right now that the relationship that we graphed has been made available to us?
The dots.
No, that's part of the graph. The dots are on the graph. How did you know where to put the dots on the graph?
Numbers.
The data. The data was in words, yes? So that's the second way linear relations can be shown to us. They can be written. Right? You have to be responsible for being able to decipher a linear relation that is written in words. Everybody cool? Everybody good with the first 2? All right. Now, the next 2 you did in the 9th grade. Table of values. Some of your teachers back in the old days or in the new days might have called it a T-chart. I don't know why. Well, I do know why. It looks like the letter T, but that's not its name. Right? I look like Johnny Galecki, but you still call me Mr. Myers. Again, Johnny Galecki looks like me because I am 3 days older. True story. What goes on the left side of a T-chart or a table of values? X.
X and Y.
X and Y if it's numbers, but we're not graphing numbers, are we?
No.
What are we graphing?
Topping.
Toppings and cost. We're graphing IVs and DVs. So what goes here?
Toppings. Cost. Toppings.
You just gonna keep saying words?
Yes.
IV, which in this case is toppings. What goes here? DV, which in this case is cost. So make the table of values. 0, 12. 1, 13, 50. 2, 15. 3, 16, 50. How far will this go? Technically, forever, if there is an infinite amount of pizza toppings. There aren't. At some point we would stop. If we had a pizza menu here right now, I would count up all the toppings and we would say that would be the extent of our domain, wouldn't it? Because we can't get any other toppings than what the place has at the pizza store. Now, of course, all that the pizza store should have is a couple of meats, a couple of kinds of cheese, and a couple of veggies. And when I say veggies, I mean mushrooms and green peppers, onions, and olives. Nothing else. All this crap of pineapple on pizza, peaches on pizza, lettuce on pizza, avocados on garbage, broccoli on pizza. I'm against Kramer on that. Okay, all that is poo. It isn't really. Some people like that. Back in the day from Panagopolis, which is what Panago used to be called, you could get smoked oysters on your pizza. Anyway, technically the line would go on forever, but really it would only go on for as many toppings as are available in the pizza store, yes? And finally, an equation. Now, how do I write that equation? So this is 3, this is the 4th way. Now, you all should remember this from the 9th grade. Every linear equation is an independent variable and then some math, which I'm going to put in an elementary school teacher cloud because it could be any math, add, subtract, multiply, divide, exponents, anything, and that will result in what? The dV, because it is what we do to the IV that gets us the dV, yes? Everyone agree? That is what every linear relation will look like. Not even linear. Everything you graph in high school will look like that. The IV is on one side, you're going to do a bunch of math to it, then you're going to get a DV. Okay? Now in this case, what is my IV? Toppings, right? What would be a good variable to assign to the IV? This isn't complicated. What would be a good variable to assign to the IV? T for toppings would be what I would use. Now, am I allowed to just say that? Can I just write an equation with a T in it?
Yes.
Technically? No, what do I have to do? I have to define that variable. T equals toppings. So T is my IV. So something is happening to T, yes? To get my DV. Let's have a look at our DV. What is happening to our DV each time? What is happening between these two levels? An addition of what? 150. What's happening here? What's happening between these two levels?
Addition.
An addition of 150. What's happening between these two levels?
Addition of 1.
An addition of 150. Now, you guys aren't unintelligent by any means. What is the one thing that we remember that all math guys are?
Lazy.
Lazy. Would a math guy write plus 130, plus 130, plus 130, plus 130, plus... What would he write instead? Times 150. Because that's the only reason we have multiplication. Because math guys are lazy. Back in the day, when you had to use a hammer and a chisel to write anything, did you want to write plus 150 100 times? No. You wrote multiplication. So, this 150 is happening to the toppings, isn't it? So 1.5 times T. Everyone agree?
Yeah.
You guys are smart kids. What's my T right here? 0. So what number would go here? 0. What's 1.5 times 0? 0. But I don't need it to be 0. My DV is 12, isn't it? So what do I have to add here? I got to add 12. Now, do I have my equation? Check. DV, IV is 1. What's 1.5? What's T right now? 1. What's 1.5 times 1? 1.5 plus 12? 13.5. Isn't that what I needed? So now we're good. Now, do I know the cost of any pizza I will order from this place?
Yes.
Yes. I got some idiot buddy who actually wants pineapple on his pizza, along with everything else. So you can tell the price. Oh, look. I'm going to tell another lie, Gabe. I'm so happy to see you during class time.
No, I bet. Can I make like a 5-second announcement?
Well, I guess you can, can't you?
Thanks. So stop. On June 1st, there's going to be an event raising money for kids' cancer.
Okay, the event's on June 1st, Kids Cancer.
That's not what the announcement is, though.
Tomorrow we have an information assembly in the pit. So the event's called Mr. Myers. The event's called the Inside Ride, and the lady's coming all the way from Toronto to talk to our school about it. So we would really appreciate if you guys could come out at lunch tomorrow and hear about
It is an assembly, but it's optional, but we really want to get as many people as we can because she's flying all the way up from Toronto to talk to us about it, so it'd be amazing if you guys could come.
It's not like you guys got anything better to do at lunch tomorrow.
Yeah.
Get your lunch and go to the pit.
Like, the rest of the lunch,
wondering.
all yours. Just, that 15 minutes would be amazing if you can come support her coming out and the
Please.
kids' cancer
Yeah.
thing. Yeah.
Cancer thing.
Well, I don't want to give too much information about it because that's what the assembly's for tomorrow.
Way to sell the sizzle, not the steak, girl.
Thank you.
See you. All right. Where was I? Pineapple, yes.
Hawaiian pizza.
You finally decide on the pizza you're going to get, which is, of course, impossible, as you all know. You cannot order pizza for a group of people because there's always somebody that wants pineapple and always somebody that can't have ham and always somebody that refuses to touch a mushroom, so you end up ordering a cheese pizza anyway, so nobody's happy. What do you mean, what do I mean? That's how it happens. What do you guys want to get on a pizza? Pepperoni, I don't like pepperoni. I want salami. I don't like salami. I want green pepper. Are you crazy? It never works. You can't do it. It's impossible. That's why 2-for-1 pizza places were invented, because nobody could decide on one kind of pizza. And don't you lie to me and tell me it always works in our house.
We get like 5 different pizzas.
Yeah, exactly. It worked in ours because you know what we were ordered? Ham and pineapple, pepperoni and mushroom. That was it. You got no options. My mom would say, go order pizza. And, can I get a large ham and pineapple and a large pepperoni and mushroom to 6884 Selkirk Street? Thank you. Click. There was no anything, because that was all we were allowed to get. Because my mom and dad didn't want to argue about anything. My dad's favorite pizza was ground beef and onion, which I thought was disgusting, and then Panago decides to start selling the bacon double cheeseburger pizza. What's on it? Ground beef and onions. They call it bacon double cheeseburger. Oh, and bacon, because it's bacon double cheeseburger. They call it that, and everyone's like, ooh, I want that. But if my dad says, yeah, get me a beef and onion, you're like, yeah. Right? Like you just did. So did we. Now I realize it's actually a pretty damn tasty pizza. It tastes a lot like a burger. All right. Everybody good? So, a linear relation is a relation with two variables. What are those two variables?
IV
and DV. IV and her boyfriend DV. Ivy. Get it? Ivy.
Yeah.
Shut up. Ivy and her boyfriend DV, whose two sets of data, okay, result in repeated change. All right? To both respective variables. Which means the change need not be the same for both of them. Okay? Here's what it looks like with a picture. The x change and the y change, which you can see quite plainly are different, repeats for the entirety of the domain and range. So basically you can make the stairs. Okay? Everybody cool? Comfy, cozy? All right. Now, if I'm not mistaken, your next page has some printing errors on it, or mine does, one of the two. Your page is right. Mine is a piece of crap. So, you guys should have I and P and Celsius and Fahrenheit, yeah? Right? Right? Yeah. Your Celsius and your Fahrenheit is, I'm going to rewrite it here in red, C, F, 032, 541, and what was the next one? 1050. Yeah, is there one more? Is there 4? 15 and 59. So all you got to do is tell me, is that linear? Yes or no? What would make it linear?
a pattern.
A pattern. Let's check. What does x change by here? +5. Excellent. What does y change by? +9. Check if it continues.
Yes.
Plus 5. What's that?
Plus 9.
Plus 9. What's that?
Plus 5.
What's that?
Plus 9.
Plus 9. Is it linear?
Yes.
Yes. Because for every 5 we go up on x, we go up 9 on y. Now notice I'm not asking you to give me the equation, I'm just asking you to see the pattern. Everybody with me? Yeah? Yeah? Yeah. Yeah. And then B is right here. 0, 0, it's I and P. 575, 10, 3,000, fitting, 67, fitting. Linear or not? No. Quite obviously not. I go up by 5, I go up by 75. I go up by 5 more, I go up by 2,925. Those are not the same. Cool in the gang? Lovely. Can everybody spot a linear equation from a table of values?
Yes.
Everybody could do it? Sweet. Now let's see if you can do it from an equation. Yes or no? Yes or no?
Yes.
Yes. Now, how many of you just guessed fitty? Be honest. Nobody? Great. That means everybody who said yes has a reason for saying yes. What was it?
There's an equation.
The IV, which is x, gets multiplied by 2 and then adds 4 every time, right? So that has to be linear. How could you prove it? You could make either the graph or the table of values, right? X, Y, 0, 4, 1, 6, 2, 8, 3, 10. Pattern, we're good. Yeah? Okay. D. Yes or no? Which is it? Why do you think it's yes?
Y is always going to be open.
Okay. Let's check. X, Y. When x is 0, what's y? Negative 1. Lovely. When x is 1, what's y? Oh, wow. I'm going to sit here quietly so I don't say something that will get me in trouble. I'm going to pretend that my honors 10 class can substitute a 1 in for x into that equation and tell me the answer. I'm going to stress that again. My honors 10 class can substitute a 1 for x and do that in their heads. Thank you. 3. Now, if this were linear, what would this next one have to be? 7. Let's check. What is it? 15. So is it linear? No. Now look closely at the last two equations. What is the only difference?
The negative sign. And
The
power.
squaring. Exponents are non-linear. And that makes sense, doesn't it? Because do exponents. 2 to the 1 is 2. 2 to the 2 is 4. 2 to the 3 is 8. It would make a curvy graph, wouldn't it? Right? Because I'd go over 1 and up 2. Over 1 and up 4. Over 1 and up. Right? Okay. E is easy. Linear or not? Yes. Because it makes a straight line. Right? You can pick any point and any other point and and then go that same distance, and it will always be the same. What about this guy? Still a line. Yep. The IV changes, and every time the IV changes, the DV doesn't change. So it would just be, what would this guy be?
2.
Y equals 2. Correct? Because it doesn't matter what x is, y is always 2. That's a straight line. G. Yes or no?
No.
No. Non-linear.
Yes.
And? Yes. And finally, our job today, the end of today's job, make a table of values and graph it. XY, XY. Now, I'm going to give you guys a couple of pieces of advice. When I am graphing, I like to find 5 points. I like to get a couple of negatives, 0, and a couple of positives. So I go with -2, -1, 0, 1, 2. Now we already know this is linear, yes? Because there is no exponent. So once I know the first 2, do I know how to fill in the rest of this chart without even thinking?
Yep.
Yes, why? Because it's going to follow the pattern. So, when x is -2, what's y? 0! Because -2 times 2 is -4, -4 plus 4 is 0. Excellently done. Next, 2. So now do I know the rest? What is it going to be? 4. 6. Who do we appreciate? Math, math, rah, rah, rah. Now graph it. -2, 0. Right? -1, 2. Right? 0, 4. Right? 1, 6. 2, 8. Now, the $1,000,000 question, do I connect the dots? Why, Ranveer? It could be linear without a connected line. Why do I connect the dots? Is this a real life situation? Or is it a math class? It's math class because we don't know what those variables are. Can I put anything in for 4 or x? Can I put in a half? Yeah. Will it get me an output? Yeah, because 2 times a half is 1, 1 plus 4 is 5. So could I put in a half? So do I connect this line? Yes. Does the line go like that? Is that correct? Yes or no? Just waiting on a yes or no. Hoping to hear a yes or a no. Why, Nadia? Because it goes on forever. Can I put in x is a billion?
Yes.
Yes, I can. And then what would y be?
Also.
Nobody wants to say 2 billion minus 4 or plus 4. But it's easy. It's 2 billion and 4. Right? Can I put in a Google for x?
Yeah.
Which is 1 with 100 zeros?
2 Google plus 4.
It would be 2 Googles plus 4, which would be 2 with 100 zeros and then a 4. So 2, 99 zeros, 4. Could I put that on a graph? If I had really big graph paper, I could. Everybody got it? Picking up what I'm putting down? Reading my mail, mow my lawn?
Nope.
Sweet. Go to the next one. -2, -1, 0, 1, 2.
Wouldn't this not be linear?
Of course it's not linear, so we've got to do every value, don't we? What is -2 squared? What's my O? Or my Y? What? 1. Yay! Because negative 2 squared is 4. 4 minus 3 is 1. What's my next one?
0.
Negative 2. Yay! What's this one? Negative 3. Yay! What's this one? Negative 2. What? How can it be negative 2 and negative 2?
Because
Crazy! Now, what's your guess for what this one will be then? 1. Brilliant. Now graph it. 0, negative 3. Well, that's easy. 0, negative 3. Right? 1, negative 2. Oh, okay, that's no problem. But then at 2, all of a sudden I'm up at positive 1. Wait a minute. That's not a straight line. I went over 1, up 1, then I went over 2 and up 4. So what would the next one be? Over 1, up 1. Over 2, up 4. Over 3, up. Well, when I went over 2, I went up 4 when I went over 2. So when I go over 3, how far up am I going to go? 9. So this would be positive 6, wouldn't it? When I go over 4, what am I going to go up? 1, 2, 1, 4, 9, 16. Someone said it. So I'd be at 13. When I go over 5, what would I be up? What was that?
20.
Jennifer at the back? 25. Why? 5 times 5. 5 squared. When I go over 6, how far up would I go? 36. That will create this shape. So when I said we went over 3, we go up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 1, 2, 3. Creates this shape, which is called a parabola, which we will talk about next year.
Okay.
Of course you know this. You did your math somewhere else, where they talk about parabolas. Everybody good?
Yeah.
Sweet! We're done.
Like our picture.